Okay, now I'm going to look at some more complicated trigonometric integrals. This is the integral of cosine squared of 5x dx. Cosine squared has this identity. Cosine squared of u is equal to 1 plus cosine 2u over 2. If it was sine squared, the only difference would be a minus in here. So I'm going to apply that and call it 1 plus cosine of 10x over 2 dx, because if u was 5x, 2u then would be 10x. At this point it's best to factor out the constant of 1/2, and then I would have the integral of 1 plus cosine of 10x dx. Both of these are integratable at this point, so I'm going to keep the 1/2 on both of these and turn it into two separate integrals. Integral of 1 dx, I'll keep the 1/2 on the second one, and the integral of cosine of 10x dx. If I integrate 1 dx, I just get x with the 1/2 in front of it. I have the 1/2. I'm going to try and turn this into cosine of u du. If I do, I know that that is equal to the integral of cosine, or what do you take the derivative of to get cosine, would be sine. However, u must equal 10x. Therefore, du is 10 dx. I don't have a 10 dx here. So I can create it by multiplying by a constant of 10 on the inside and a 1/10 on the outside. It's reciprocal. Otherwise, you change the value. Now you have the integral of cosine of u du, which will equal the sine of u. So this is going to equal the sine of u, which is 10x. So your answer is 1/2 x plus 1/20 sine of 10x plus c, because this is an indefinite integral. Now you're going to have integrals involving cosine squareds and sine squareds throughout the next few sections. This one on the bottom is a little more straightforward, but then we're going to apply it also in another one. The derivative of secant is secant tangent. I have a tangent. So first I may try and change them into u's because I have a 4x instead of simply an x. So to make this into secant to the 6th of u, tangent of u du, in this case I'm letting u equal 4x. Du, its derivative, would be 4 dx. So you may have to multiply by a 4 and it's reciprocal out front. Now I have everything in terms of u. What you're going to want to do is factor out 1 secant, because the integral of, or the derivative of secant is secant tangent. So if I was to call this secant to the 5th of u, to get secant to the 6th, I have one more secant and this tangent. And now I believe I have 1/4. Let me move this up to make sure it's visible. I have 1/4, and I believe I could call this u to the 5th, and all of this would be my du. Now if I integrate this, I have to raise it to the one higher, u to the 6th divided by 6. So the final answer is going to be 1/24 u to the 6th plus c. Now I'm going to replace in for u, what was u in this case? I didn't write this out. U is secant, and the derivative is secant tangent, which you have. So in here I'm going to replace it with the secant of 4x. Now that's rather difficult. You have to factor 1 secant out, and you realize the derivative of secant would be secant tangent. So you can have a u to the 5th du.